Next thing we will be talking about are slopes of parallel and perpendicular lines. Parallel lines have the same slope. So if I have two different lines, they are parallel if their slopes are equal. If M1 is equal to M2, parallel lines would look like this. They would never touch each other. They could look like this. So notice how the pairs of lines that I'm drawing are going in the same direction. They could both be vertical. Those are parallel. So those are parallel lines. I know this says two non-vertical lines, but vertical lines can be parallel. It says that there because technically the slope of a vertical line is undefined. And so I can't say this undefined slope equals that undefined slope. But I can say if two lines are both have undefined slope, then they're parallel because they're both vertical. Perpendicular lines have opposite reciprocal slope. So you can see that there's this negative sign here, and the reciprocal just means that there's a flip in there. And perpendicular lines, unlike parallel lines, perpendicular lines do intersect. They do touch each other. More specifically, they touch each other at a right angle. So if that's a line, then the other line would look like this. Its perpendicular line would look like that, where it's forming a right angle. Okay, so let's do some examples where we just determine what the parallel or the perpendicular slope would be. So for example 5, if I know that the slope of a line is -3/8 and I'm looking for a line that's parallel to that, well, parallel means same slope. So the parallel line would have the exact same slope. But the perpendicular line would have the opposite reciprocal slope. So we're going to change the sign so it would no longer be negative, and we're going to flip it. So it would not be 3/8, but it would now be 8/3. For example 6, parallel lines have the same slope. So if a line is parallel to a line with slope 20, then that line would also have slope 20. If the line is perpendicular, it would have the opposite reciprocal slope. So because the 20 was positive, I'm now going to have a negative. 20 is 20/1. I'm going to flip that, take its reciprocal to get a -1/20. If the slope of the line was 0, its parallel line would have the exact same slope, which would be 0. Keep in mind, if a slope of a line is 0, it is a horizontal line. 0 is 0/1, and 0 doesn't have a, let's take a step back. Perpendicular line would have opposite reciprocal slope. Opposite means change the sign. 0 has no sign, so there is nothing to change. 0 is neither positive nor is it negative, so I can't change the sign on it. Reciprocal means flip it, but if I were to flip it, I get 1/0. Please do not put that on your paper. That's very cringe. That is undefined. If the slope of a line is 0, the perpendicular line would have slope that is undefined because you cannot have 0 in the denominator. You cannot flip that. So now let's look at some examples. So let's say we have a line that passes through the point -1, 2 and is parallel to this line here. We want to find the new equation of that line. Key word here is parallel, which tells us that we're going to have the same slope as this line over here. So what we need to figure out is what is the slope of that line over there. One of the fastest ways to find out the slope of the line is to put it in slope-intercept form. How do we get to slope-intercept form? We solve for y. So I'm going to add 3x to both sides of this equation. It looks strange. So I get that y is equal to 3x plus 4. And the reason that I did that is because now this line is in slope-intercept form. And because it's now in slope-intercept form, I should be able to just look at the line and take the number that's in front of x, and that is my slope of 3. So now I know that the slope of the line they gave me was 3. Because they told me the line was parallel, I'm going to use that same slope. So I want the equation of a line that passes through the point -1, 2 and has the same slope of 3. There's lots of different ways that we could write this. One quick way we could write it is we could write it in point-slope form. Point-slope form simply tells us to fill out a point and the slope. Well, I'm going to use the point that they gave us of -1, 2 to fill out the point. So I will have y minus y1, which would be 2, is equal to m. M is the slope. I know that this line is parallel to a line of slope 3, so it has the same slope of 3. X minus x1. X1 is the x-coordinate from the point that they gave us, which is a -1. So we are subtracting a -1. So the last thing I'll do is I will just one of the last things I'll do, rewrite this like I'm turning the minus negative into a plus sign. So here is our answer in point slope form. If we had been asked to write this line in, so that's an answer. Perfectly good answer, 100% credit, because it doesn't say to use a specific form. If we had been asked to write this line in slope-intercept form, we would then need to take it a step further and solve for y. I just want to point that out really quickly. I'm going to erase this. I'll copy over the line here. I'm going to distribute the 3 on the right side of the equation to get 3x plus 3. And then to get all the way to slope-intercept form, I would need to solve for y. So I'm going to add 2 to both sides to get that y is equal to 3x plus 5. And this would be the equation of the line in slope-intercept form. Okay. Now let's look at example 9. Find the equation of a line that passes through the point 6,8 and is perpendicular to the line defined by 2y plus 5x is equal to 10. We still need to go and find the slope of the line that they gave us, because they told us that we want to be perpendicular. And I know that perpendicular means opposite reciprocal slope. But I need to find the slope of that line so I know what am I taking the opposite reciprocal of. Again, the easiest way to find the slope of that line is to put it in slope-intercept form, because once you are in slope-intercept form, you can see the slope. It's the number right in front of x. It's the coefficient of x. So I'm going to put this line in slope-intercept form by solving for y. So I have 2y is equal to, I'm again putting the x term in the front just to stay consistent. Solve for y, divide everything by 2, divide by 2, divide by 2. I get that y is equal to -5 over 2x plus 5. So now that I have this line in slope-intercept form, I can see that the slope of this line, I'm going to be a little bit more specific here. This is the old slope, right? That's the old slope that they gave me. The old slope was -5 over 2. But they tell me that they want me to be perpendicular. Perpendicular means I need the opposite reciprocal slope. So opposite means change the sign. It will no longer be a negative number, and to flip it. So it will no longer be 5 over 2. It will now be 2 over 5. So we had to go find the slope of that old line first so that we knew what the opposite reciprocal was. We also had to know that perpendicular means to take the opposite reciprocal. So now I know the slope of the line is 2/5 and it passes through the point 6,8. So I'm just going to fill out the point slope version of the line. It's very easy to write. Y minus y1, y1 is 8, the point that the line goes through, is equal to m. The slope of the line that we will be using is 2/5. It's the opposite reciprocal. And then we have x minus x1, and x1 is 6. So this is the answer in point slope form. You could also do what we did in the last example and solve that equation for y to then have the equation in slope-intercept form, which I'm not going to do for this example, but you very well could do that. So if I had asked you to give that equation in slope-intercept form, you would then take this equation, and if you were to solve for y, then you would have slope-intercept form.